Good morning. Rise and shine, 8:30. Cool, so many people. Welcome to this session on The Architect. My name is Yuval Lowy. I'm the principal of iDesign, where we specialize in .NET architecture. In fact, I've been an architect my entire career. Before I founded iDesign, I was the corporate architect of a Fortune 100 company in the Silicon Valley, and I managed the architecture department. And before that, I was a division architect. Before that, I was just the architect. Some other things, I'm also the Microsoft regional director for the Silicon Valley. I'm an author, I speak at conferences. But this session is not about me. Anyway, normally my sessions are all about techniques and code, and look at the things I did yesterday. It was always Kung Fu with WCF and a service bus. But this session will have no design. There would be no technology here. But to quench your thirst for the semicolons, here's a big semicolon curly brace. And let's just move on. And unfortunately, we have to start with some bad news. And unfortunately, it's not even news. I mean, it's bad, but it's not bad news. The industry we're in, the software development industry, is in a deep crisis. And what makes this crisis so acute is that it's multidimensional. Virtually every aspect of software development is broken. Look at cost. As semicolon pushers, we don't care about cost. It's not money that we have to pay, but somebody has to pay for it. And quite often, the cost of developing the software exceeds the benefit to the customer. My question to you, in what world it makes sense? Quite often when you or your managers budget and estimate something and the customer signs off on the cost, yes, the cost for 1.0 is this, but the thing is going to be in maintenance for another 7 years. It's going to cost you like this. If you're going to say on day one to the customers and cost you like this, they're going to say, no, thank you. We're better off with the fax or the phone or the mainframe, anything besides spending that. And even if the initial cost of development and the cost of ownership is somehow contained, typically it's not. Sometimes they ask you to do something, and they say, no, we can't do it. Well, what do you mean you can't do it? It's just code, just write more code to do it. When you're saying you can't do it, you're basically saying the cost of doing it would be so prohibitive, there's no point in doing it. That's what you're really saying. When you have too many of these, we can't do it, you say, oh my God, what do we do now? Let's take it outside to the woodshed and shoot it in the head like the rabid dog that it is. And we'll do a clean slate. Software doesn't die peacefully in bed. No. Doesn't ride gracefully into the sunset. No. Take it outside, shoot it in the head. We'll do a clean slate, you say. We'll wipe the slate clean, we'll do it anew. We know how to do it. We'll do it now, yes. Only to end up 3 to 5 years later with another clean slate. If you think about it, the clean slate is an admission of failure. You have failed to do it right in the first place. Should never have ended this way. Look around you. Nobody in any other engineering discipline is doing a clean slate. So if the airline needs to change the jumbo jet engine, they throw away the whole jumbo jet. If you have a skyscraper, you need to fix something in the sewer in the 12th floor, you just throw away the whole thing. Those are over the building, start again. You need to fix something inside the machine, do you go and throw away the whole machine because you couldn't fix it? No, nobody's doing it for the simple reason there's no economic sense in doing a clean slate. But in software, this is so bad, you've all grown to accept the clean slate as a natural phase in the life cycle of all applications. You all know at the end you're going to have to take it outside and shoot it in the head. Then there's schedule. Deadlines means nothing to our industry, to developers. You know what are deadlines? They are these things whooshing by. You're sitting in your office. Here's another deadline. Oh, here's another one. Why does it take so long to develop it? It's not just the whole thing. It's just the customer says, I want this feature. You go and you go through change control board and somebody assigned to the list to do of some developer. In a few times, they're supposed to develop it, test it, integrate it, redeploy it. 9 months later, you're going to get the feature. I have news for you. The customer doesn't want the feature 9 months from now. The customer wants the feature now. Why can't you deliver now? Now, it's bad that you are late. It's bad that deadline means nothing. You slip the schedule. To make it even worse, quite often the schedule slip is hidden. Up until the release, you don't know you're going to miss the schedule. Yes. Yes. Why? How come it was hidden? It's not just you, it's everybody. I'll pick on Microsoft. It's a big, nice, juicy target. VS 2010. They were supposed to release it by March 2010. And I know that because in November 2009, they asked me to help them produce the launch event in Las Vegas. So we set up a conference, we invite speakers, inserts in MSDN magazine, the whole thing. In January, they contact me and say, we can't do January, it's going to be April. I said, what? They said, no, we can't do March, it's going to be April. I say, what? We have to move it to April, they say. Really? You know what it means to move a conference by months? After all, the attendees have booked their airlines and all the speakers with Swiss cheese calendar have booked that week. It's like moving a mountain. So up until January, they didn't know they couldn't ship in March. And it's not as if it's the first time they're doing Visual Studio, is it? Then there's requirements. Developers often solve the wrong problems. The customer wanted this, you deliver that. Hopefully, with enough overlap between these two things, the customer is actually going to want to use your system. Hopefully. Why this constant failure to communicate with the customer? Then there's all these things the customer wants, but you're not going to do. Why? Because it's too hard, because you don't know how to do the single sign-on, because. There's always excuses, but the customer still wants the feature. Quite often, a combination of schedule slips and cost constraints means that by the time you actually do release the system, too much has changed in the system domain, and the system is obsolete by the day it's released. I've seen system developed for 8 figures. Multiple times I've seen it, that the customer paid for it, took the system, put it on the shelf, never used it. Too much has changed. My question to you, is it a surprise that things change in the user domain while you're working on your software? No, we know that's the case. So why do you fail to accommodate it? Why this surprise, requirement change? Yes, requirements change. What a surprise. Requirements do change. That's what they do. They change. If requirements wouldn't change, none of us would have a job. Right? Yes. So why do you pretend it doesn't happen? Side by side with not meeting requirements or doing the wrong thing, you have gold plating. Developers adding bells and whistles and features and things that nobody really needs or asks for. And this additional gold plating typically increases the complexity and the cost and affects the schedule. Let me show you something. You can open up Visual Studio. Now I have a question for you. I don't know if you've seen this, but this is the code editor in Visual Studio. This is actually not your grandfather's RTF editor. This is a WPF editor. That's right. That lets you do amazing things like this or that. My question to you, would anybody ever do this? Would you ever write code like this? This is pure gold plating. This adds no value. Do you know how much effort it went into doing a WPF editor? In fact, the benchmark was, let's do it just like the RTF editor. Don't do anything new. It has to look just like the RTF editor. Most of you don't even know it's WPF now, not the old RTF editor. And it's not, by the way, that I couldn't do it. If I really wanted to develop in font 78, I would go to Tools, Options, Font 78, and I would do this. Nobody ever does, but the option was there. How many of you think the performance of VS 10 is adequate? So how many of you think it's inadequate? Funny thing. So for us, how this thing performs is a core feature. And yet, it doesn't perform well, but we have this. Side by side with unmet requirements, you see gold plating. Sometimes there's not enough core functionality. If the system would only do this, it would be so much better. It doesn't do it. Then there's staffing. In the average team, it's been measured, there's a 10-to-1 ratio, one order of magnitude between the best developer and the worst developer in the team. 10-to-1. I'll prove it to you. How many of you, the guys that go to TechEd, the guys that cares about improving yourselves, last week, let's not go more than that. Last week, somebody back at the office asked you something, but the thought that went through your head was, you can't really be asking me this. I'm shocked. Really? Now, I assume you didn't deliberately go out of your way to hire the worst developer you could find. You went through some minimal screening, some phone screening, some interviews, something. And still this? Really? By the way, is your worst developer the worst developer on the planet? No, there's probably another order of magnitude in that way. And by the way, is your best developer the best developer on the planet? No, there's probably another order of magnitude on that side. End-to-end, the spectrum is 1,000-to-1. What does it mean? You can have 1,000 monkeys versus one good guy. And that one good guy does more work than the other 1,000. That's what it means. My question to you, what kind of management overhead and org chart and thing you have to do to manage 1,000 monkeys? Do you think you're going to meet the schedule? Remain within adequate cost? And to make it even worse, you guys, the ones that actually know how to read and write, it doesn't matter if you know how to read and write, because 2 years from now, so some new college graduate is going to try and maintain your code. They don't understand what you did. As a result, they're going to butcher it. Do you have any doubt they're going to butcher it? Butchering going once, butchering twice? No, they are going to butcher it. Yes. We have it completely upside down. We have new code written by the smartest guys, and we have the dumbest or the most inexperienced guys trying to maintain it. We should have it the opposite. We should have new code written by the dumbest guys, and then the smartest guy trying to figure out what they're doing. But we don't do it this way. Now, you guys also, my experience is you have higher ethics. You care about improving yourself. You went to TechEd. Did anybody force you to go to TechEd? Did the boss go to you and say, you go to TechEd or else? No, you took a week away from your life, from your family, from work, and came here. All the work is still waiting for you next week. So you care about what you do. You do. So if you care about what you do, and you know those guys can't really do it, you're going to try and actually do both. You can do the new stuff and try and help with the old stuff. But nobody can do perpetually 200% position. As a result, we have burnout. Burnout, yes. I'm going on site. Who did this? Who did that? Was the architect? And I said, no, don't talk to Joe. You talk to Joe, he's going to spontaneously combust. Yes. Most organizations systematically burn the top resources. I mean, you know, the high-end software industry, the ones that recognize the need, somebody like iDesign, is relatively small. At the end of the day, most companies don't do architecture on a regular basis. You tend to do it actually on big cycles, every 3 to 5 years. So even if you have, say, an architect, so every 3 to 5 years, the architect is going to do the architecture. How much time is the boss going to give the architect to do the work? 3 weeks? 4 weeks? 5 weeks? 6 weeks? You're never going to get this much time. Just architecture, just arranging the blocks. So if the unit of management of architecture is weeks and the cycle is measured in years, that's 52-to-1 ratio. Let's make it 50-to-1. That's 2%. So you spend 2% doing architecture. You think you can ever be good at it? No. So those that recognize it go to iDesign. But they're a minority. Most people don't recognize this chain of thought I just went with you. So I founded the company 11 years ago. So by now I get to see the same customers every 3 to 5 years. Sometimes it's a different name, a different building. There was an acquisition. And I say, hey, I was here 5 years ago. I worked with this architect. His name is Will. Is Will around? And they said, no. One day, Will just put the castle down and walked out. He was totally burnt out, he said. He's now selling his yacht around the world. He sent us a postcard from South Africa. There was something there about him not wishing to hear about any deadline measured in less than seasons. Yes, selling his yacht around the world, I say. What did they do to scare away the most precious resource? Then there's quality. Software has bugs. Software is synonymous with bugs. I don't like the word bug. Bug implies it's like this, it's a pet. It's a little fluffy pinkish animal. You feed it. It purrs back as you pet it. It's a hideous, monstrous defect. That's what it is. Really. How did the bug appear in the code? You put it there. I mean, it didn't contract it from another infected piece of software on the drive. It sneezed on it. It got the bug. No, you put it there. My question to you, why did you put the bug in there? Is your customer surprised when you have bugs? No. In fact, you have so many bugs, you have a defect tracking system. Think about it for a second. You have so many bugs, you need an IT system to track them. You start a new project. You select your configuration management tool and your compiler and your defect tracking system. You haven't written a single line of code. You know you're going to need a system to track your bugs? Yes. And it's horrible. And we all know it's this way. I used to ask this question. If your system was a jumbo jet, would you dare fly it? And nobody raised their hands. And then one day, one guy in the back says, I say, you? You are the one? He says, oh, yes. With my team, the plane wouldn't even taxi. And then developers give themselves the moral excuse why it's happening. It's our stuff. It's so complex. We can't deal with it. Really, it's about complexity. Let's talk about jumbo jet. What is more complex, the jumbo jet or your piece of software? Well, how can you compare something that flies in the sky with lines of code? I don't know. We have to find some metric, like how many moving parts. Let's compare every rivet and every moving part in a jumbo jet to every line of code. How many millions of parts are in a jumbo jet?
4 million.
Easily. Is your piece of software 4 million? We have a guy from Boeing here. Really? Well, maybe it's the size of the team that worked on it. I mean, bigger team are difficult to manage and such. But did you have thousands of people working on your software project? Maybe it's the time we're supposed to be in production. Do you know that most jumbo jets are older than their pilots? Maybe it's the money that went into doing it. Or maybe it's any way you want to measure it, the jumbo jet is more complex than your piece of software. We can agree on that. And my question to you is, what is more reliable, a jumbo jet or a toaster? No, a jumbo jet is more reliable than a toaster. What kills more people, jumbo jets or toasters? Toasters kill more people. It's not a very complicated device. You put a piece of bread, you press the header, it goes up. You press the header, it goes up. You press the header, it goes up. Nothing will stop Mrs. Jones from taking a fork and shoving it in there and trying to get the piece of bread out. They try all sort of scheme to avoid Mrs. Jones electrocuting herself. Doesn't matter. And then when jumbo jets blow up, we set an inquiry to find out how could they have blown up out of the sky. I mean, this is an abnormal behavior. We don't expect them to blow up. We expect Mrs. Jones to get electrocuted, though. So with insane level of complexity, we have virtually impeccable quality. So it's not about complexity, is it? And this problem I discussed so far has been around for a long time. This is not new. Let me share with you something. If you go to Wikipedia, there's an entry there called the software crisis. And what do they say? They say projects are running over budget, over time, low quality, doesn't meet requirements, unmaintainable. Do you think I have to go to Wikipedia, look at those 5 bullets and craft the previous 2 slides? Would anybody here fail to come up with the previous 2 slides? It wasn't news to anybody. Now, the most amazing thing about this screenshot is not that there is an encyclopedic entry about the software crisis. I mean, think about it. That alone is pretty amazing. Our industry is so broken, there's an encyclopedic entry that says how broken it is. I don't see a mechanical engineering crisis, civil engineering crisis, electrical engineering crisis, aeronautical engineering crisis. No, software, yes. That alone is pretty amazing. The amazing thing is that the term, the software crisis, was coined in 1972. My question to you, how many of you weren't even born in 1972? How many of you were programming for a living in 1972? A few. We can safely assume that this crisis predates all of our professional careers. It's been around forever. Forever. One of the nasty things about long-term problems is there's no quick fix. Because I assure you, if there was a quick fix, somebody's already would have applied it over the last few decades. The fact that nobody has done so means there's no quick fix across the entire industry. For your project, you can fix it tomorrow. We'll discuss it. For the entire industry, it may take decades. The unit of measurement here is going to be decades. It already is, by the way. Just go through it. But like I said, that doesn't mean that you can't solve it tomorrow. If you look at the way most organizations write software, they do it in an entirely chaotic manner. I say it's as if a mob is trying to write software. What does it mean a mob is trying to write software? The problem with a mob, you can't predict what the mob is going to do. It's not repeatable. Are they going to burn this store, lynch this guy, loot this place? Who knows? Sometimes they skip a store, then they loot the next store. It's a mob. In your world, it would look like this. It took you a year to do the previous software version. Does it mean it's going to take you a year to do the next? No. Could it be 2 years? Yes. By the way, if it took you a year, does it mean it couldn't have been done in 6 months? No. It's supposed to cost like this. Is it really going to cost like this? Nobody knows. You know, that's a mob mentality. This amoeba, it's flowing around. Nobody knows what it's going to do. There's no productive process. People always cry, we don't have a process. Yes, you do. Except the process most people have is not designed to increase the developer's productivity. It's designed to maximize the inherent degree of inefficiency. It's overbearing, suffocating, cancerous thing. Doesn't actually do any work. There's no structured knowledge retention. If somebody has figured out how to do something, if somebody moves away, the knowledge is gone. The mob leader is gone. The mob disperses. Development is hardly ever done against a development standard. We always do it like this, and then it's like that, and it's like this. No, sling it, see if it works. Now, this, by the way, is not inherently specific to software. If you look at all other engineering disciplines, in fact, you can generalize it to all other knowledge-intensive areas, like even medicine, biology, and such. They all actually did that for a long period of time. Then they went through an act of maturity that made them stop doing it like this and do it very differently. Everything was like this at some period of time. And we haven't gone as an industry through this act of maturity yet. In fact, we practice software as if it's the dark ages. Yes. Now, if what I discussed so far was absolutely uniform, every company in the world would be like this, there would be no point in having this session. However, there's plenty of examples of companies that are doing a great job. And they're always on schedule, on budget, and quality. Those that attended my pre-con know exactly what these three mean. How many of you attended my pre-con, by the way? A few? Yeah. And they're not that rare. I mean, it's not that common, but it's not that rare. What I see is maybe 1 in 7 is doing a good job. If it would be 1 in 7,000, there would be no point in having this session. But if it's 1 in 7, you say to yourself, well, that's common enough that we can ask ourselves, what are those guys doing which is different? Maybe they're using better technology. No, they actually tend to be even more conservative than most. They don't strive to have a bigger gun, they just improve the aim with the gun they already have. Maybe they have smarter people. No, they actually don't need heroes and supermans to save the day. Now, the fact that side by side with the mob, we have those are doing a good job is a very characteristic of a pre-industrialized society. If you look at the Dark Ages, most people had short, brutish, ugly, filthy life. That would pretty much capture it. Was this 100% uniform? No. There were islands of knowledge. In the monasteries, the monks were copying the ancient scrolls of the Greek, dealing with modern algebra. By and large, all the way up to calculus you learn in universities was already done in the 10th century. Yes, so cubic equations in the monastery, and outside the mob is eating from the latrine. That will pretty much capture it. Side by side. Side by side. Yes. Now, if you look at other engineering disciplines, all the other engineering disciplines have matured, and their form of maturity was that you can't just decide, I'm a doctor. If I were to put a sign on my door and say I'm a doctor, I will go to jail. You can't just say, I'm a civil engineer, I can design bridges. No. Only certified civil engineers can sign on the blueprint for the bridge. But who is a developer? Whoever says he's a developer. Can you study journalism? Yes. Physics? Sure. You write a few HTML pages, now you're a developer. Do you have to study anything? No. Not at all. Not even computer science, which is not at all the same as software engineering. In fact, the way you practice software is not being practiced as an engineering discipline. And to give you an analogy here, a simple analogy, if you look at, say, at ancient Rome had 1 million people in it. Do you know what it's like to feed 1 million people? To give them water? You can't use pail out of the well and just give them with buckets water. You have to have running water for this. What about taking the sewer away? You have to have plumbing for the sewer. The logistical challenges are so immense that after Rome fell in 476, it took humanity 2,000 years to repeat the achievement. It was Chicago in 1890. To have 1 million people in one place. It is that high of a bar to meet. The Romans met it 2,000 years prior. Now, they did some amazing things. Like, for example, to get running water after they finished tapping to all the local springs and such, they had to funnel water from far away and use gravity to feed Rome. They built huge aqueducts. Some of them go all the way to the Pyrenees in Spain, 2,000 kilometers away. And they figured out that it has to be in a constant 0.8 degree slope. Because if it's more than that, by the time the water reaches Rome, it's going to blow up all the pipes. If it's shallower than that, it wouldn't flow. Too much friction in the pipes. It's to be a constant 0.8 degree. What does it take to build an aqueduct through valleys and gorges and tunnels and mountains on beautiful arches and have this beef-line shot into Rome? What kind of engineering it requires? What kind of trigonometry? Oh, and by the way, you have to do all of that using Roman numerals. What does it take to build the Colosseum? Amazing structures that survived for thousands of years. Legend has it that when they budgeted the Colosseum, oh yes, when they budgeted the Colosseum, they calculated how many bricks they would need. They ordered all the bricks plus one. They built the Colosseum. They took the one extra brick, put it on top, no mortar, just put it on top, just to show that they could actually do it. So clearly, amazing feats. My question to you is different. How come Rome didn't have skyscrapers? Well, maybe it's technology. No, it's not. The Romans had cement. How many of you know the Romans had cement? Good. They could have built skyscraper. I mean, that's what we did. If you try and put 1 million people in one place, what happens to the real estate prices? It goes up. So what do? You try and build higher on the same piece of land. It's trivial. That's how Chicago did it. They built 9 stories, by the way. That was a skyscraper in the 19th century. It wasn't a monster glass and steel building like we have today. No, it was brick and mortar and cement and 9 stories. How come the Romans never did it? Tell you why. It's not just about the technology. How many people in Rome knew how to design an aqueduct? Or the Colosseum? 1, 5, 10? Does it matter? If you only build one Colosseum, one guy is good enough. If you start building skyscrapers, you need thousands of them. The more they didn't scale, there is a fundamental transition between the craftsman, the master craftsman, and the engineer. It's a question of scale, really. And in a way, we're kind of like in a pre-industrial society. There's islands of knowledge, people who know how to do it, surrounded by a sea of muck. That's kind of like it. Software is not perceived as a profession. If you say you're a software, people say, oh, he's a geek. Probably still lives with his parents in the basement. He's a hacker. Something is wrong. He's not really mature. I see it all the time. Once a month, I go to some customer. Next week, I'm in Germany. I come back through immigration in the US, and they ask me, what do you do? If I say I'm in software, they say, OK, move along, kid, move along. If I say, I'm an engineer, they say, welcome back, sir. It's a perception. Now, let's talk about your salaries. In the average team, there's 10-to-1 ratio between the best developer and the worst developer. Is the guy who's 10 times better getting paid 10 times more? How about 3 times more? No. No. Interesting. Interesting. Why is that? Because the HR lady decides not using a table. She has years of experience, technical rank, poof, that's your number. So I say that this is the HR salute. You know what? You do this for commodities. A bushel of wheat is that, and a barrel of oil is that. That's it. How many tons? That's it. Done. When things are interchangeable, when things are commoditized, you do it. But are these really just warm bodies in cubicles? So what is the commodity here? A warm body in a cubicle? And is one warm body the same as the next? To the HR lady, the answer is yes. Put differently, she doesn't value what the geek is doing. One geek is the same as the next. Well, in many ways, she's correct. One mob member is the same as the next, really. She can't tell them apart. In fact, when it comes to, say, manufacturing, you do decide on the salary for manufacturing workers this way. You take somebody who's not very well educated. You say, here's a machine. You need to do bang, 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 and move the part. Take another part and say, bang, 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 and move it apart. And there's not much skill required in doing it. And if you don't like it, I get somebody else to do it. You know, OK, so for manufacturing, for low-skill work, I would expect this kind of an approach. But is this good for software? We discussed the knowledge gap. It's both a knowledge gap and a skill gap. We know that there's a huge gap between what developers know and what they should know. But it's not just developers. It's also managers. Most managers haven't got the foggiest idea how to properly execute the project. Most managers actively kill their projects. Most managers devolve to a deathmatch. Let's code like hell and see if it works. The worst are managers that had a lucky strike early on in their career. They keep hoping for another lucky strike, ending up with another deathmatch. Our entire pipeline in the industry is broken. What feeds our industry is supposedly universities. But nobody teaches software engineering. Now, some universities dispense software engineering degrees, but these are not software engineering degrees. They're computer science degrees masquerade better to the industry, but they're still computer science degrees. Why am I picking on it? In every other knowledge-intensive area, we've made a separation between the science and the engineering. They're absolutely not the same. For example, can you study chemistry? Yes. And do graduate and undergraduate and post-PhD in chemistry and you understand everything about the spin of the electron in the level 3 and so on? Good. Can you design a refinery for me? No. We have chemical engineers for that. Chemical engineers deal with other problems besides the electron spin in the level 3 of the S3 of the quantum. No. There's this reaction. It requires this much pressure and this much temperature for so long. So if you have this big vat, your energy bill is going to be like this. You say, oh my God, that's a huge energy bill. Here's what I'll do. I'll have a pre-chamber where I'm going to have even a higher temperature and higher pressure. I'm going to put a little bit of a catalyst. The catalyst costs me something, some platinum, something, but it gets the reaction going. I'm going to keep it for a short period of time. Then I'm going to flow it to a bigger vat, low pressure, low temperature, but for a longer period of time. But time I have, money I don't. And I'm going to rinse and repeat, build a refinery. Can you study physics? Yes. Can you design for me a rivet for an airplane wing? No. For that, we have mechanical engineers. Note, I'm not saying mechanical engineers don't know physics. They probably know as much physics as anybody who doesn't call themselves physicist actually know. But they have to take into account things like friction, fatigue, vibration, dust. The first thing the physicist says is, let's assume no friction, no fatigue, no this, no this, no this. Let's not talk about it. And they would know how to choose a particular piece from a particular. And the fact that we can design a part, does it mean it's good? No, it doesn't mean anything. If nobody can manufacture it, it's no good. Back to the drawing board. In our world, it would be, you can design a system, but if your code monkeys can't build it, it doesn't matter. OK, so maybe they can they can manufacture the part, but not within very tight tolerances. Sometimes it's too big, it's too wide. No good. Yes, you can manufacture it, but the tolerances vary. Back to the drawing board. Maybe the tolerances are OK, but there's no way of, once this part is inside the machine, reaching into it and replacing it. It's not maintainable. Back to the drawing board. It doesn't mean anything you can design something. The design means nothing if you can't maintain it. Even if you can maintain it, but every once in a while the machine blows up and kills the operator, it's also not good. It's not safe. Back to the drawing board. Doesn't matter if you have a good software system, a good design, if there's no security, it's no good. The same problem, by the way. I'm sure you can see the analogies here. Can you study biology? Yes. And you can do a post-PhD in the mitochondria DNA and how it generates the ribosome and the, you know what, I have a headache. Can you tell me if it's the flu or brain tumor? No. For that, we have doctors. Can you study computer science? Yes. What is computer science? Computer science is a branch of discrete math that was nailed to the floor more or less by Euler and Gauss in the 18th century, a little bit before computers. If you're lucky, you would study Turing machines, which is the 1940s. Good. Does anybody teach the equivalent of this stuff for software? No. Even if they masquerade it as a software engineering degree, it's a computer science degree masqueraded better. It's not it. Nobody teaches that. Now, the other engineering disciplines didn't used to in the past as well, but they have matured to the point that they can actually do it. For example, we discussed civil engineering. Civil engineering, the Romans went doing it because they didn't have skyscrapers. Civil engineering was born more or less in the 12th century with the age of the cathedrals in Europe. You know, building a giant cathedral consumed 4% of the nation's GDP. Today's numbers would be like, $1.5 trillion building, just to give you a proportion. Almost all first-generation cathedrals collapsed. Yeah, so you spend $1 trillion, it collapses. Well, you can't just build it one brick on top of the other brick. You have to bring into account how the very weight of the building deforms the building, and how to distribute the load, and have cantilevers and arches and all sorts of things. These are engineering problems. And they had to figure it out, and they figured it out. And by the 12th century, there's Padua in Italy that are teaching civil engineering. Mechanical engineering matured in the 19th century. If you look at the late 18th century, they already had locomotives. But every locomotive was a work of art. Every locomotive was done by hand, just like a software system, by the way. Now, you have two locomotives. They have their own parts. They have their own nuts and bolts. Every locomotive engineer would walk around with a bag full of nuts and bolts because there's no way of saying it if the end station is going to be nuts and bolts that fits your train. There weren't even standards for the gauges. By the late 18th century, the British Isles had the very first grid of trains that enabled later on the Industrial Revolution and so on. But it was quite common for the train to stop in the middle of nowhere. The passengers would disembark and embark on a new train that goes on this section of the line that has different gauges. That was their version of interoperability issues, right? I mean, all the passengers go from this train to that train is no different than us reaching the facade of the system and doing dot equal, dot equal, dot equal, dot equal, dot equal. It's the same thing. Yes. But that has changed. That has changed. You know what changed it? The US Civil War, with mass production of rifles. Up to that point, most armies used smoothbore muskets, where you take some powder and you put a lead ball on top and you shoot it. And then the ball goes somewhere, nobody knows. And so they used to usually align, long lines of soldiers holding this musket, everybody press the button, and maybe it's going to go somewhere. But if you rifle it, then it gives it angular momentum, and you can use ballistic to actually do amazing shots. And my question to you is, what does it take to rifle a bore? What kind of machinery it takes to do it? Can you design for me a machine that does rifling? Oh, and does it repeatedly because the pitch has to be constant? And while we're talking about it, how about have every barrel fits on every receiver so that soldier can actually have interchangeable parts? They had to figure it out. Yes. Electrical engineering matured after the First World War with radios. Everybody wanted one. You think the internet was big? You think the television was big? It's nothing compared to the impact that radio had. Nothing. Everything after the radio was incremental improvement. Up to that point, news is what you heard from your neighbor. I mean, that was it. And the scope of your world was the nearby town. That was it. All of a sudden, you hear what's going on the other side of the planet. Or from New York, you can hear everybody. I mean, it was just an unbelievable transformation. Everybody wanted one. Now, it's not that Marconi didn't build a radio in the 19th century. Of course he did. But what does it mean to produce millions of vacuum tubes and have them work together on the, well, they had to figure it out. Our industry hasn't gone through this matching act of maturity. Hasn't. In fact, if you look at it in general, engineering is not the same as science. Engineers take some scientific principle, apply it towards a practical end. There has to be a widget. They always do it against requirements. They don't just do it because it's nice, because it's cool. They do it because somebody wants it. They would avoid gold plating because there's no economic sense in gold plating. All engineers affect the public. The litmus test for the engineer is the engineer can kill somebody. Tell me what kind of engineer you are, I'll tell you how you can kill somebody. Scientists are very different. They don't have to be anything practical. How does he know something is good? Another scientist says it's good. How could we possibly train people by these guys, expecting them to do this work? We can't. The pipeline is broken. As a result, who picks up the slack? We do. You hire a new college graduate, we know that person is useless for 2 or 3 years. That's like a statement. Whatever you learned is meaningless. Then you learn the ropes, and hopefully 2 or 3 years from now, you can touch the keyboard. What's wrong with that picture? We know that's also a sign of a pre-industrialized society. How did you learn to be a painter or a mason in the Dark Ages? You join the guild, and you study with the master of how to lay the bricks, and you become a brick master, or whatever. Yes. This is exactly the way it's done in a pre-industrialized society. At which point people say, hold on a second. I understand civil engineering and mechanical engineering, but those things have matured in the 12th, 19th century. Software is so volatile. Things change so much. I mean, we can't teach it. By the time they're going to graduate, they're going to be obsolete. Really. I have a question for you. What changes more, medicine or software? Of course, medicine. Think about all the new treatment, all the new drugs, all the government regulation, new equipment, new procedures, research, papers. It's an insane churn in body of knowledge. Do we give up training doctors? No. Here's how we train doctors. We send them for medical school for 7 years. Did we teach them how to operate the MRI device at the hospital? No. What did we teach them instead for 7 years? For 7 years, we teach them what we call the core body of knowledge of medicine. It's the things that are guaranteed not to change by the time they graduate. Because by the time they graduate 7 years from now, humans are still going to have 2 legs, 2 kidneys, 1 liver, 1 heart. So for 7 years, 2 legs, 2 kidneys, 1 heart. Both my sisters are MD, and I saw both of them for 7 years doing 2 kidneys, 1 thing. I used to make fun of them. I said, are we done with the 2 legs, 2 kidney stuff? Are we ready? Are we good with 2 kidneys? They graduate. Do we let them touch patients? In our world, we let them touch the keyboard? Heavens forbid. Instead, for 5 years, they don't sleep. They're going to do residency. Would you feel comfortable if you knew that the doctor touching you in the ER is actually a resident? But there's also a doctor there in the background. Actually, he's not a resident anymore, supervising the residency that they're not killing too many people. Oh, they kill all the time. Read a book called Complications. Anybody read that book? Read it. Anyway, for 5 years, I don't sleep. And then 12 years later, we let them touch patients. You know what? We should do the same in software. We have our own equivalent core body of knowledge. Think about all the things we know about architecture. Client-server, multi-tier, this, that. Think about all the things we know about process. Waterfall, why not to do it. Stage delivery, agile, Scrum, this and that. All the things we know about technology. Java versus .NET versus this, virtual machine, not virtual machine, this and that. Think about tools. How could it possibly be that we have developers coming out of school that have never checked in or checked out a file in their life? They don't know the difference between a merge and a branch. Would you have a mechanical engineer coming out of school and saying, nuts, bolts, could you point one for me so I can actually... Are you sure it goes inside the thing? Nuts? Who knew? Who knew? Nuts and bolts? What a novel concept. But we get these guys that don't even know the difference between a merge and a branch. I'm not saying they should use TFS. Pick one tool at school and go through some exercises of merging and branching and doing this whole thing. We don't do it. Think about all the things we know about methodology. Procedural versus object-oriented versus service-oriented, component-oriented. Should we not be able to fill a 3 or 4 years program just doing this without even mentioning Euler and Gauss? Yes. Anybody's doing it? No. How did the industry respond to the crisis? Well, the industry we have today is very different than the industry 20 years ago. 20 years ago, say, even more than that, late 80s, early 90s, the only guys who did software were the weirdos. The math heads. They would be wearing long Hawaiian shirts with long hair, and those would be the software guys. All that has changed through the 90s. All of a sudden in the 90s, there was a ton of money to be made in software. There was this huge sucking sound as our industry sucked in people from everywhere else. It was like a modern gold rush. People left their day job doing whatever they were doing. Now they were a developer joining a startup. Next March, they're going to go IPO and be millionaires. That was the plan. In the Valley, I've seen friends that had PhDs in biochemistry or whatever, but they knew how to write an HTML page, got themselves developers, joined the startup. Source of market, next March, millionaires. That was the plan. There was this huge infusion of low-grade workforce, really. Guys who couldn't even read and write, by and large. And as a result, the term the software architect kind of has emerged. But is a software architect the architect in the same sense that a civil engineering architect is an architect? No. The equivalent of that, by the way, if you have one, is your CTO, kind of. The software architect is actually a software engineer. The software architect has to look at the engineering aspects of software, how to make it maintainable, extensible, reusable, secure. These are no different than the question a mechanical engineer asks, how do I make this part manufacturable? How can I make it safe for the user, within tight tolerances, repeatable, and so on? It's the same set of questions. Now, why do we call it the software architect? Because the term software engineer is already occupied. It's occupied by developers, programmers. So it's actually an inflated term. When we say a software architect, we actually mean a software engineer. But we have to inflate the term because the software engineer term is occupied by programmers. And if you have a title developer, you're merely a code technician. Sometimes I call them in frustration code molesters. And there's no shame in being called a technician. In all other engineering disciplines, we have made a separation between the engineer and the technician, the doctor and the nurse. Yes, we have made that separation. In our world, no, let's call him a software engineer. The reality is software architecture is fundamentally engineering. And software development is manufacturing. I actually agree with the Agile lady doing this. It is manufacturing. You manufacture particular orders of zeros and ones on some kind of a media and you ship it. It's manufacturing. But it's not the same as engineering. Yes, for the code guy, this is good. It's not good to do it for the engineer. You don't decide on salaries for engineers this way, by the way. In fact, for anything you value, you never do this. Right? If your child is sick, do you open the yellow pages and pediatrician? Look at AA pediatrician. Hello? How much is it? $200 an hour? No, not too much. AA pediatrician. How much does it cost? $175. I'll get back to you. Do you choose a pediatrician like this? Or do you ask who is the best in the world for this? Well, it's Dr. Schopphausen in Zurich. How much does he cost? Well, he charges $100,000 for a visit. Fine, you say, I'll sell my house, I'll get another mortgage, you fly to Switzerland. If your child life is at risk, would anybody here fail to do it? But it's a factor of millions of percent more expensive than AAA pediatricians. Why do you do it? Oh, simple, you value it. But it's a perception problem. The Agile lady doesn't value the added value of the software architect or the engineer. What I find is that the key for resolving the software crisis is to practice software engineering or software development as an engineering discipline. And if you look at the guys who are doing a good job, the 1 in 7, they're not doing it well because they have better technology or better tools or smarter guys. They actually treat it very differently than the mob. They look at it as an engineering domain and apply classic old school engineering principles. In fact, in the abstract, all engineers do exactly the same. All engineers, doesn't matter if it's electrical, mechanical, civil, aeronautical, doesn't matter, rely on a core body of knowledge of design best practices. Nobody ever tries to invent the wheel in every project. Nobody ever tries and open every design decision from the very, very beginning. So if you're designing an airplane wing, the first design meeting on the wing is balsa versus plastic. Why? And plastic is cheap, it's lightweight, it's not so strong. Some argue in favor of plastic, some don't like the plastic. No, it's going to be aeronautical aluminum for a particular grade, and here's a family of alloys. Done. There's no discussion. It's not open for debate. Yes. And they know what is the core of the best practices. They don't invent anything. They take all of that and they leverage in a particular context. They just tweak the abstract best practices to their domain. That's it. Nobody tries to invent anything. In fact, it's very important that they wouldn't do it. You don't want to be too creative about these things. They all rely, of course, on a technological or scientific foundation, which makes a difference between a civil engineer and an electrical engineer. They all follow an analysis methodology of sort. Analysis is a big elephant in the room. Nobody talks about it. How do we teach architects to analyze? Oh, no. The tooth fairy is going to leave them a note how to decompose the system. Why? You can't teach analysis? I assure you, you can. It's done all the time. Let's look at doctors. You go to the ER. There's a doctor asking you questions. Show me your tongue. Do you have a headache? What they're doing now, they're doing basically a triage. You don't go to see the doctor in the ER based on the order you arrived. You get to see the doctor based on how severe you have. The first thing you have to rule out is brain hemorrhaging, because that is measured in seconds. No brain hemorrhaging. Okay, now we're talking maybe, do you have some pain here? Maybe some heart attack? Now it's measured in hours. Nothing measured in hours, go to the end of the line. Right? Pretty much. Now, would you like to go to an ER where the doctor there has his or her unique way of doing the triage? No. I want you to do the triage just like every other doctor on the planet is doing it. Don't consult a crystal ball. Don't use cloves of garlic. I want it to be done just like everybody else. Right? Right. If it is possible to teach analysis to millions of doctors on life-saving matters, I assure you it's possible to teach analysis to software engineers. You look at the requirements, here's the design. Absolutely. It's done all the time. All engineers have a set of supporting assumptions. If you design a bridge, you say, the bridge is never going to collapse. If you design an airplane, the assumption is, the airplane is going to fly forever. Forever. No. The opening statement is, this bridge is going to collapse, period. What are you going to do about it? What kind of a factor on strength are you going to put on it? Opening statement, this airplane is going to crash. Well, I'm going to have 7 navigation systems, 3 fuel pumps, 4 engines. Right? In your case, who is ever going to attack it? Who needs security? It works, ship it. No one needs to deal with this race condition. It's never going to happen anyway. Right? So in the abstract, we don't deal with software like all the other engineers deal with their stuff. And I assure you, in the abstract, all engineers do exactly the same. That includes, of course, the 1 in 7. If somebody in the electrical engineering domain would be trying to develop what they do using software methodology, it would look like this. So suppose you're an electrical engineer charged with building a television. You would go to the parts store downstairs, get some capacitors, resistors, LEDs, LCDs, fill a whole shopping basket with it, go back to the office, pour everything on the carpet, take a soldering iron, start soldering it, hoping to end up with a television at the end. And by the way, that's how you manufacture it. You can do it per television this way. They're all going to be unique works of art. Do we do television this way? No? Funny thing. But that's how we do software, isn't it? Absolutely. We don't do it like other engineering disciplines. In fact, if your average civil engineer or electrical engineer would see how we do it, they're going to be shocked. Shocked. Now, like I said, the key for resolving the crisis is not succumbing to this. Since all other engineering disciplines have gone through this act of maturity through various points in history, all of them ending up doing exactly the same. They're doing this. I have a simple solution for the software crisis. Let's do the same. Let's apply the same principles, the same approach to software. And doing that is the job of the software architect. Software engineering is what software architects do. The term is misleading, very misleading. I mean, let's face it, if you're only going to do it 2% of your time, maybe 3%, it's already misleading, okay? And so if the owner of this is this architect, and by the way, you don't need more than an architect per team, sometimes even less, okay? Just like you don't need for every mechanical part, for every, you don't need teams of engineers next to the same number of technicians. One engineer can create a lot of work for many technicians, I assure you. I mean, what do we have more at the hospital, doctors or nurses? It's a simple thing, right? And so if this is what software architects need to do, let's further define the term of software architect. There are actually 2 types of architects. The first type is enterprise architects, sometimes being called the corporate architect or the chief architect. And like I mentioned to you before I founded iDesign, that is what I did. And the enterprise architect tried to utilize the economy of scale of the company. What does it mean? If you only have 4 guys at the shop, there's no economy of scale. But if there's 400 or 1,000, I assure you there are some commonalities between what those guys are doing. So if there is commonality, let's bubble it up to this corporate framework and have everybody hang off it and specialize for their need, and that would be good. So the enterprise architect typically charged with building such a corporate framework, providing direction, guidance. We will use WCF. We will move to the cloud. If you have a framework that you have to do, maybe you manage other architects in a corporate architecture body supposed to crank up this framework, design it, evangelize the concept, and so on. My experience is that, by and large, most people who have the title architect are not enterprise architects. Quick survey here. How many of you are enterprise architects giving this definition? Okay. You get the idea. It's 1 in 50, 1 in 100. The other type of architect is a solution architect. Sometimes just being called the architect, or maybe the lead developer. The scope of their responsibility is a particular application. They don't care about anything else. Yes, they may pay a lip service and say we care about the other things. They don't care. They only care about their product, their application. And the solution architect has many responsibilities. They are responsible for the application top-level design, and sometimes also the detail design, depending on where is the handoff point between the architect and the developers. They're responsible for providing technical leadership. Now, what it means to be a technical lead has drastically changed since I started in this industry in the early 90s and today. In the old days, technical leads showed developers how to do something. In the old days, there was no Google, there was no MSDN. They had to show them how to do something. They didn't know. Developers don't need help in how to do something anymore. You know why? Because they have a wonderful tool called Voodle. What is Voodle? They go to Voodle, they type whatever they want, they copy and paste, and they move on. I call this voodoo programming. Who said it's any good? Because Google bubbled it up? That means you can plug this code, really. Do you understand what it does? No. I wish we could block all search engines in development environment. It would be much better if they could actually try and figure it out, understand fully what they're doing. Would a mechanical engineer take a blindfold, go to the parts store, randomly pick a part, and say, that's the one I like, and just try and shove it into the machine? Oh, that's very inspiring, isn't it? Randomly, let's pick a part, let's move on. You won't be able to change the way developers deal with the question of how. That's the way to deal with it. But what developers desperately need help with is what? They don't know what to do. There's so many ways and options of doing pretty much anything. And the search engines just make it worse because they will bubble up to them all the different ways of doing something. So a good technical lead today tells developers what to do. Don't bother with the how. They'll figure out, they're very good at figuring out the how. Part of technical leadership is also reducing the relative complexity of the application by providing infrastructure. Should every developer have their own credential management, their own logbook, their own diagnostics, their own event publishing, their own this, their own that? No. So a good technical lead would come up with this infrastructure, preferably even before developers are assigned, and so that they hit the ground running, working against the infrastructure. The architect has to work with the product and project managers. And I had a whole day on this collaboration. All of Sunday was spent doing that, on this particular collaboration. The architect has to contribute to project planning, not tracking the project, but the architect is the only one who understands the dependency between the modules or the services, what is the critical path of integration, can estimate the effort involved, understand the risks, and help with the project plan. Absolutely. I'm curious, given this definition, how many of you would classify yourself as solution architects? Yeah. Like I said, it's probably 50 to 1, the ratio of two types of architects. Now, if these are the responsibilities, you can actually take this and make it a rec and post it in monster.com, right? I mean, it's a responsibility set. The next question is, what are the set of skills required to succeed doing that job? Which is nothing more than classic engineering, if you think about it. Because in the abstract, all engineers do exactly the same. In fact, the message of today is, yes, it will take decades for the entire industry to get out of the dark ages. But that doesn't mean you can't establish this island of knowledge and sanity and hygiene around yourself tomorrow. You absolutely could. Just apply engineering principles to the problem. So what are the skills required to succeed doing it? The architect has to take an active leadership role in process. You can call it process and project leadership. It's almost by elimination, let's face it. You think the managers care? No, they don't. They just want to see code like hell, okay? Developers, no offense, but you know, they're like this. They don't know any better, they just want to code. So who's going to do it? You're going to do it. And I assure you, unless somebody owns it, it's not going to be done. They have to be able to come up with the architecture against modern design patterns, as reflected by the technology at hand, which is very important. They have to do the analysis, go from requirements to design. They have to be able to communicate to developers their idea. I assure you, if developers don't understand your design, they're going to butcher it. Now, I don't expect the developers to come up with a design, but I expect them to understand how to build the system. You have to communicate to them. In that respect, our developers are much worse than the lowest level construction monkey. You go on a construction site, there's these big, burly guys. There's a table covered in nylon with a stack of diagrams. And they go to it and start fumbling, say, oh, that's the one, let's start building this. Our developers can't even do that. Time and time, I go and do a design review, and the architect confides in me and he says, you know, I gave them a good design. They butchered it. And I say, really? A good design is not a good design if it's a good design in your head. It's not a good design if it's a good design on a whiteboard. It's not a good design if it's a good design in a document. It's only a good design if it survived through development, ending up as working bits on a customer machine. Then it's a good design. You have to ensure the survivability of your design. And the first step is communicating to them what they need to do. Capture it graphically somehow, ensure they understand. You have to be able to validate the architecture. You knowing 3 years later in hindsight, that wasn't a good idea after all, is nice, it's of no use. 1 week into the project, you need to know if this design is good or not. How do you validate your design? All engineers validate their design, by the way. If you're designing an airplane, there's going to be a little mock-up airplane, a little wind tunnel, you try and see if the design makes sense. Or for the civil engineers, it would be a little cardboard building with plastic trees showing it to the city or whatever. Everybody validates their design. If you're a mechanical engineer, you're building a car, it's going to be some kind of plywood and cardboard, wax car, and you sit to see if the elbows can move and what the... everybody's validating their design, somehow. Why shouldn't the architect do it? You have to. 1 week into the project, you'll be dealing with architecture validation. Now, if these are the skills and these are the responsibilities, you can distill it further. And you could say that the architect is actually 3 things in one. The architect is a process lead, a technical lead, and a design lead. It's not just about architecture. Architecture is 2%. To succeed, you have to do these. Now, the architect actively wears 3 hats. Now, sometimes, depending on the phase of the project, one hat is heavier than the other 2, but you always have to wear all 3. In fact, you cannot succeed without wearing 3 hats. Doing each one on their own is a form of failure. If you just do design, but nobody can execute it, you have failed. If you have this great technology, but your process is a bunch of monkeys, then it's not good either. If you just do process, you'll be worshipping the process, but not doing anything. You have to practice all 3, and what I find is it's a continuum. The process affects the technology, which is related to design. Design affects the process. It's all the same, actually. It's called success, by the way. Now, what I find is that the evolution of the career path of the individual architect is quite uniform. And it actually tends to reflect the understanding that our industry had what the job means and entails over the years. Because the realization that the architect needs to do all of these 3 things is a very modern observation. We've now matured to realizing this. That wasn't the case 20 years ago. If you were to go and corner in the early 90s a team and you would say, if you were to be able to go back in time and went to ask them, who's your architect? They would ask you, Archi what? The term doesn't exist. At most, you had a technical lead. Through the 90s, because of the introduction of low-grade workforce, the term the architect has emerged. So we can tell the sheep from the goat, the yolk from the oats, the chaff from the wheat, and all of that. We need to understand who's the guy that can actually read and write. The term the architect has emerged. But as a result of the last decade, we realized that you need to do all of these things. Now, if somebody is both a technical lead and a process lead and design lead, that somebody is, for all intent and purpose, the technical manager of the project. What does it mean to be a technical manager? It means that you don't manage developers. Developers typically don't and shouldn't report to the architect. There's some paper-pushing, pointy-haired Dilbert-style manager somewhere doing that. But if you own the process and the design and the technology, you manage all technical aspects of the project. And that will probably be the best definition of what is the architect. What is the mission statement, being the technical manager. In fact, I find that the individual architect career path often reflects that. The same guys that in the early 90s were called technical lead and through the 2000s were called the architects are now maturing into the technical manager position. Same guys, maybe a little bit heavier, gray hair, losing some hair, but same guys. And while I sensed that, I was always a bit suspicious about it because everybody see what they see, and you don't see what you don't see. So you always have your own bias as to what you see, right? And I tend to interact with the very high end of the spectrum. I tend to interact with people who understand they need my service and such, and now it's so biased, and I see what I see. But I sensed that, and I couldn't extrapolate it. 2 years ago, I got a wonderful confirmation for it. Most of the authors for MSDN Magazine are also speakers at TechEd. And I've been a contributing editor to MSDN Magazine for more than a decade. Now, the magazine is based in New York. I'm in California. It's all over email. But 2 years ago, the entire magazine staff was here. And most of the authors were here as well. And they had this nice gala reception. It was nice to put a face on an email and shake hands with all these guys. And they shared with us a readership survey. And the readership survey, it took me 2 months to just get permission to show you the next slide, was done very exhaustively over like 100,000 readers. I mean, it was a very exhaustive survey. And the survey was simply, who is the MSDN reader? Now, the MSDN Magazine, how many of you read the MSDN Magazine? Of course. As the alpha geek, you have to read the MSDN Magazine, right? It's the pull no punch, hardcore magazine for the super geek, right? So we'd assume the true developers read MSDN Magazine. Let's look at the survey. 96% of the readers manage people, project, or both. Really? Are they really alpha geeks slinging code? No, they manage people, project, or both. 96%, that's like 100%. That means a solution architect. And on average, these are not large things, 12, 11. They're not enterprise architects, they're solution architects. I mean, you would assume that, the geeks coming out of school read MSDN Magazine and then managers. No. It's a solution architect reading MSDN Magazine. Gender heavily biased toward being male. I mean, we've got a few ladies gracing us with their presence here, but by and large, this is it. The most amazing number here is the average age, 39.6. Now it would be 41. These are not the young kids coming out of school. They don't read anything. They voodle it. Who reads MSDN Magazine? It's the old bull. Getting savvier. Sharpening the sword. Those are the guys reading MSDN Magazine. But you know what? Look at it. This is these guys, according to the survey. So I can spend the whole day on this topic. So let's just finish it. We can take some questions. So some resources for you. I have here some mini CDs with additional resources to what I discussed here, mostly on technology and some process. These are all that I left. You also have the CD link at the bottom. I actually have I've dedicated my career to training architects. That's what we do. And once or twice a year, I do a class I call the Architects Masterclass. I'm doing the next one in California in November. The only promotion I do for these classes is events like this. I don't even list it on the website because otherwise I get hundreds of emails. So if you're interested, it's not too soon to send me an email now. Okay? And what else? There's more resources. But 40 more seconds, so maybe a question or two, and then we call it quit. Questions? Yep.
So if the developers had to fly their software, it would be better software.
A great observation. If developers had to fly the software, it would be better software. I completely agree. Yes. There's I long time had an idea that you should take the defect tracking system, and whenever a defect is assigned to a developer, you send them electric shock as well. Okay, so we're out of time, guys. Thank you so much.